Welcome everyone. Today, we'll explore welding processes as outlined in API 577. This standard is critical for ensuring quality and safety in welding operations, particularly in the petroleum and petrochemical industries. Our goal is to understand the principles behind major welding methods and how API 577 guides inspection and quality control. Welding is more than just joining metals, it's about achieving structural integrity and reliability. API 577 provides a framework for inspection and quality assurance, ensuring that welding procedures and personnel meet stringent standards. In this session, we'll cover 8 major welding processes and their applications. Welding is a critical fabrication process used to join metals by applying heat, pressure, or both. API 577 provides guidelines for welding inspection and quality assurance in the petroleum and petrochemical industries. It emphasizes proper procedure qualification, welder performance, and defect prevention. Understanding different welding processes is essential for selecting the right technique for specific applications, ensuring structural integrity, and meeting safety standards. This presentation covers 8 major welding processes: SMAW, GTAW, GMAW, FCAW, SAW, SW, PAW, and EGW, detailing their principles, applications, advantages, limitations, and inspection considerations. Each process has unique characteristics that influence weld quality, productivity, and suitability for various materials and environments. Principle and applications of shielded metal arc welding or SMAW. SMAW, commonly known as stick welding, uses a consumable electrode coated with flux to create an arc between the electrode and the workpiece. The flux coating decomposes during welding, producing gases that shield the molten weld pool from atmospheric contamination and forming slag to protect the weld bead. SMAW is versatile and widely used for construction, pipelines, and maintenance work due to its portability and ability to weld in various positions. It is suitable for ferrous metals and offers simplicity in equipment setup. However, it has limitations such as slower deposition rates and frequent electrode changes. Proper electrode selection and adherence to API 577 inspection guidelines are crucial for ensuring weld quality and preventing defects like porosity and slag inclusions. Features and advantages of gas tungsten arc welding or GTAW. GTAW, or TIG welding, employs a non-consumable tungsten electrode to produce the weld. An inert shielding gas, typically argon or helium, protects the weld area from oxidation. GTAW provides superior weld quality and precision, making it ideal for critical applications such as aerospace, nuclear, and piping systems. It can weld a wide range of metals, including stainless steel, aluminum, and exotic alloys. The process allows excellent control over heat input and weld bead appearance, resulting in minimal spatter and high-quality joints. However, GTAW is slower and requires skilled operators. API 577 emphasizes proper shielding gas flow, electrode preparation, and inspection for defects like tungsten inclusions and lack of fusion. Process details and applications of gas metal arc welding or GMAW. GMAW, also known as MIG welding, uses a continuously fed consumable wire electrode and shielding gas to create the weld. It offers high deposition rates and is suitable for automated and semi-automated welding in manufacturing and fabrication industries. GMAW provides clean welds with minimal slag, reducing post-weld cleaning. It is effective for thin to medium thickness materials and can weld ferrous and non-ferrous metals. The process requires stable power sources and proper shielding gas selection to prevent porosity. API 577 guidelines stress monitoring wire feed speed, voltage, and gas coverage to ensure weld integrity. Common defects include lack of penetration and porosity, which can be mitigated through proper parameter control. Key characteristics of flux cored arc welding FCAW. FCAW is similar to GMAW but uses a tubular wire filled with flux, which provides additional shielding and alloying elements. It can be self-shielded or gas-shielded, making it suitable for outdoor applications where wind may disrupt gas shielding. FCAW offers high deposition rates and is commonly used in heavy fabrication, shipbuilding, and structural steel work. It handles thicker materials effectively and allows welding in various positions. However, FCAW can produce more smoke and requires slag removal. API 577 recommends careful control of wire feed, voltage, and flux composition to prevent defects such as slag inclusions and porosity. Proper inspection ensures compliance with quality standards. Mechanism and benefits of submerged arc welding or SAW. SAW involves forming an arc beneath a blanket of granular flux, which shields the weld from atmospheric contamination and stabilizes the arc. This process is highly efficient, offering deep penetration and high deposition rates, making it ideal for welding thick sections in pressure vessels, pipelines, and structural components. SAW produces high-quality welds with minimal spatter and excellent mechanical properties. However, it is limited to flat or horizontal positions and requires mechanized equipment. API 577 emphasizes flux cleanliness, proper flux recovery, and monitoring of heat input to prevent defects like incomplete fusion and cracking. SAW is widely used in industries requiring strong, durable welds. Applications and process of stud welding. Stud welding joins a metal stud or similar part to a workpiece by creating an arc and applying pressure. It is commonly used in construction, automotive, and shipbuilding for attaching fasteners, insulation pins, and other components. The process is fast and efficient, producing strong joints without requiring holes or additional hardware. Stud welding can be performed using drawn arc or capacitor discharge methods, depending on the application. API 577 guidelines highlight the importance of surface preparation, proper stud alignment, and inspection for defects such as incomplete fusion or misalignment. This process enhances productivity and structural integrity in various industrial applications. How plasma arc welding works. PA uses a constricted arc formed between a non-consumable tungsten electrode and the workpiece, with plasma gas passing through a fine-bore nozzle to create a high-energy plasma jet. This process offers precise control and deep penetration, making it suitable for welding thin materials and critical joints in aerospace and nuclear industries. PA can operate in two modes, transferred arc for welding and non-transferred arc for cutting. It provides high-quality welds with minimal distortion but requires specialized equipment and skilled operators. API 577 stresses proper gas flow, nozzle condition, and inspection for defects like lack of fusion and porosity. PA is ideal for applications demanding accuracy and reliability. Use cases and characteristics of EGW. EGW is a vertical welding process that uses a consumable electrode and shielding gas, often combined with flux, to weld thick sections in a single pass. It is commonly applied in shipbuilding, storage tanks, and structural components where vertical joints are prevalent. EGW offers high productivity and eliminates the need for multiple passes, reducing welding time. However, it requires precise control of heat input and electrode feed to prevent defects such as lack of fusion and excessive reinforcement. API 577 emphasizes monitoring parameters and inspecting welds for compliance with quality standards. EGW is advantageous for large-scale projects requiring efficiency and strength. Comparison of welding processes. Each welding process has distinct advantages and limitations. SMAW is portable and versatile but slower, GTAW offers precision but requires skill, GMAW and FCAW provide high deposition rates for fabrication, SAW excels in thick sections but needs mechanization, SW is fast for fastening applications, PAW delivers accuracy for critical joints, EGW is efficient for vertical welds. Selection depends on material type, thickness, position, and project requirements. API 577 provides guidance on inspection and quality control for all processes to ensure safety and reliability. Key inspection guidelines. API 577 outlines inspection practices to ensure weld quality and compliance. These include verifying procedure qualification records, PQR, welder performance qualifications, and adherence to welding procedure specifications, WPS. Inspectors must check for common defects such as porosity, cracks, lack of fusion, and undercut. Non-destructive testing, NDT, methods like radiography, ultrasonic testing, and magnetic particle inspection are recommended for critical welds. Proper documentation and traceability are essential for maintaining quality standards. Following API 577 ensures structural integrity and safety in welded components. Summary of key points. Understanding the characteristics, advantages, and limitations of different welding processes is vital for selecting the appropriate method for specific applications. API 577 provides comprehensive guidelines for inspection and quality assurance, ensuring safe and reliable welds. By adhering to these standards and implementing proper training, parameter control, and inspection practices, industries can achieve high-quality welds that meet performance and safety requirements. Continuous improvement and awareness of emerging technologies will further enhance welding efficiency and quality.